This is the standard form equation of a parabola. In this video, I will show you how to graph a parabola if you're given the equation in standard form, but I will also show you how to create the standard form equation if you're given a version of the equation that is not in standard form. Also, if you're given certain information, like any 2 out of 3 of the following, focus, directrix, vertex, given any 2 of those, I will show you how to find the standard form equation of the parabola. Now, some parabolas are vertical, like this one. They open either up or down. On the other hand, some parabolas are horizontal, like this one, opening either to the left or to the right. Notice how the model changes. If we're dealing with a vertical parabola, the x part of the equation is squared. If we're dealing with a sideways or horizontal parabola, the y portion of the equation is squared. So keep that in mind. So as soon as I see that the x portion of the equation is squared, not the y part, that tells me that I am dealing with a vertical parabola. So it's either opening up or it's opening down. Now, I know whether it will be up or down based on this number right here. If this is positive, that means it's opening up. If it's negative, it opens down. So because this is a negative 16, I know this is a downward opening parabola. Now, I'm just going to redraw that little sketch. Because a parabola comes with 2 key features. There's a focus somewhere in the interior and a line called the directrix in the opposite direction from the way it's opening. So our graph will ultimately have this look to it. Let's start with the vertex, which in my little thumbnail sketch would be this point right here. At a glance, we can know the vertex when it's in standard form. It will be the opposite of this number and the opposite of this number. Be careful of the order, though, because let me just write this down real quick. Vertex. The x-coordinate of the vertex has to come from the x part of the graph. All right? So even if the y part of the equation is first, it will still give you the y-coordinate of the vertex, which would be second. So sometimes it's backwards, so be careful. But in this case, the x is first and the x is first here, so it's in order. Looking at the y minus 2, I will have a positive 2 for the vertex. So these are the coordinates of the vertex. Let's go ahead and graph that right now. Okay, so the vertex is at -1, 2. All right, remember, I already know this is a downward opening parabola. So next, let's find the location of the focus. The focus can be found if we know the p-value. Notice that the p-value is the distance from the vertex to the focus. Okay, from the vertex to the focus, that's the p-value. If it's up or to the right, the p-value will be positive. If it's left, like this, see the p-value is negative, or if it's down, the p-value will be negative. So if I can find the p-value, I can find the focus. Now, notice that in front of the parentheses on the right side of the equation is this 4p. That means that this negative 16 has a value of 4p. This is 4p. So I can make a little equation out of that. 4p is equal to this negative 16. So dividing by 4 on both sides, that tells me that p is equal to -4. I know that the focus is below the vertex in this problem. The -4 tells me that the focus will be -4. It will be down 4 exactly from the vertex. So if I go down 4, I'm right here. This is my focus. It also tells me the directrix, because the directrix is the same distance in the opposite direction. So for example, if the focus is P up, then the directrix will be P down. If the focus is P left, then the directrix will be P to the right. Okay, so in this case, the focus is 4 down, which means that the directrix will be 4 up. So the directrix will be right here. Okay, we need 2 more points in order to actually graph this parabola. And to find those 2 points, we're going to use something called the focal width. The focal width is the width of the parabola at the height of the focus. Alright, so if you go to the focus and look from side to side, that's your focal width. Or in sideways parabola, this would be the focal width from here to here. How will I find it? The 4p is actually your focal width. So look at this worked out equation. See the negative 12? Looking at this, I know that the focal width will be 12. Focal width is always positive. So looking here, this number will tell me the focal width. See how it's negative 16? So the focal width will be positive 16. So I know that the width of the parabola at the focus is 16 across. That means if I go 8 to the left and 8 to the right, that will give me a total of 16. So if I go 8 to the right, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to have to go a little bit off the graph. And 8 to the left, 1, 2, 3, 4, 5, 6, 7, 8. Okay, sometimes you have to go off the grid. Okay. So we can use that information to go ahead and draw a nice parabola. Okay, that's it. We've drawn it. Now, they want us to record all of the key information. Our directrix is a horizontal line, and we will call it y equals 6. All right, it's a horizontal line at 6. Horizontal lines always have the equation y equals something. The vertex we found was -1, 2. The p-value we discovered to be -4. The focus. So the focus is right here. This is the point -1, -2. And the focal width was 16. Alright, so that'll be it for problem number 15. Let's practice that again on problem number 16. Notice that the y part of the equation is squared. And we know that if the y part is squared, we are looking at a horizontal parabola. So it will open either to the left or to the right. We are going to look at the 4p value, the number that's right here. If it's positive, it should open to the right. If it's negative, like this -12, it will open to the left. So since this value 8 is positive, I know that it will open to the right. So I'm just going to make myself a tiny sketch to remind myself of what's happening. So I know I'm going to have a parabola that is opening to the right, which means that I will have a focus on the inside right here and a directrix in the opposite direction. Okay, and of course the vertex would be this guy right here. Speaking of the vertex, let's go ahead and say what that is. The vertex will be the opposite of these two numbers, but be very careful. The x-coordinate of the vertex will come from the x portion of the equation. So this +3 will give me a whoops, why did I put a -2? I said this +3 will give me a -3 x-coordinate of my vertex. This +2 will give me a -2 y-coordinate. The y-coordinate has to come from the y part of the equation. Let's go ahead and graph that vertex. So -3, -2 is right here. Always keep in mind that this is a parabola opening to the right. Next, we need to find the focus. To find the focus, we need that p-value. But remember that this number right here is 4p. In other words, 4p equals 8. Dividing both sides by 4, we find that p is equal to 2. Now, right from the beginning, we knew that the focus would be to the right of the vertex. The p-value tells us that it will be 2 to the right. So the focus will be right here. It also gives us the directrix, because the directrix should be the same amount in the opposite direction. So if I go 2 to the left, here's my directrix. Okay, make it a dotted line. Okay, now we just need 2 additional points in order to graph this parabola. For that, we will use the focal width. This number right here tells us the focal width. The focal width is 8. Remember that the focal width is always positive. Even if this were -8, the focal width would still be +8. The focal width tells us the width of the parabola at the focus. So since the focal width is 8, if I go up 4, that will give me a point, and if I go down 4, that will give me a point. So again, you can see if I go from one side of the parabola to the other, that's going to be a total focal width of 8. So that gives us the point that we need in order to graph the parabola. Okay, all we need are 3 points. And that's it. So now let's go ahead and label it up. The directrix is vertical, as you can see. So let's circle vertical. Vertical lines always have the equation x equals something. This is a vertical line at -5, so x equals -5. We found that the vertex was at -3, -2. We found that the p-value was 2. The focus is right here. That's -1, -2. And again, the focal width was 8. So that is going to be it for problem number 16. For number 17, we are given the general form equation, and we need to convert it to standard form. You know, that's with all the parentheses and everything like this. Pay attention to which variable is squared. That makes a big difference. X is squared this time. So that means we're shooting for this type of equation with the x part being squared. So for that reason, we're going to make sure that the x terms, all the terms that have x's in them, will stay on the left side of the equation. Everything else should be moved to the right-hand side of the equation. So add or subtract as needed to move everything else to the right-hand side. That will leave us with x squared plus 8x. Okay, and then on the other side, now I will have a positive y minus 20. So we need to complete the square. Half the middle squared. Half of this is 4. 4 squared is 16, so that's plus 16. We're going to need to add 16 to the other side to balance that out. Completing the square makes it so that if you factor, you will always get the same binomial twice. So this will be x plus 4 times x plus 4. If the middle term is positive, they're both positive. Meanwhile, combining like terms over here, we have y minus 4. So we can write this as x plus 4 squared is equal to y minus 4. Now, this is it, all right? This is the standard form equation. It should be bothering you a little. Normally, there's a number here in front on the right-hand side. and that's our 4p value. So we use that for stuff. So the fact that like say if I were to put some unnecessary parentheses right here, there's no number in front. What do you think about that? What if I told you there is a number? It's just invisible. What would that number be? Of course you're thinking of the number 1. So if it helps you, don't leave this in your final answer, but for the other things that we need to find, like the p-value, we are going to understand that this number in front is the number 1. So I see that they left me space for the equation. I didn't notice that before. So I'm going to go ahead and write it down here without the 1. So we have x plus 4 squared is equal to y minus 4. Fine. There's a standard form equation. The vertex is going to be the opposite of these. Please make sure that the x coordinate is coming from the x part of the equation, even if it's backwards. So we will have negative 4 because of this. See, this is a little bit weird because they both have 4's in them. So don't think that the negative 4 is coming from over here. It's not. This negative 4 is coming from the x part of the equation. It's just that they're opposites. And the y coordinate will be positive 4 because opposite of this. So there's my vertex. The p value, well, like I said, this 1 is 4p. So 4p equals 1. Dividing both sides by 4 tells us that p is equal to 1/4. So that was it for number 17. Let's practice that again for problem number 18. Notice that the y is squared. So that tells us that we're dealing with this form of the equation where we will want the y portion of the equation squared. The x part of the equation will not be squared. So for that reason, we're going to make sure that the y terms stay on the left side of the equation, and everything else is going to move to the right hand side of the equation. We will add or subtract as needed. So we're going to have y squared plus 10y is equal to negative 16x plus 7. I subtracted this, added that, boom, there you go. So now I need to complete the square. In fact, I'm just going to move this equal sign over a little bit more, leave space to complete the square. Half the middle squared. Half of this is 5. 5 squared is 25. So I'm going to have plus 25 right now. Now I need to do plus 25 on the other side as well to balance out that change. If I factor this, I'm guaranteed to get the same binomial twice. So y plus 5 times y plus 5. Meanwhile, over here I have negative 16x plus 32. Because I have the same binomial twice, I can go ahead and write y plus 5 squared. Okay, so now I have this portion of the equation done. Notice how this portion of the equation, you're normally going to have a value in the front, this 4p. Like looking at this example right here, I've got negative 12 with in front of parentheses. So we need to make that happen. The way you create the parentheses is you factor out whatever this number is in the front. So I'm going to take that negative 16 and factor it out. So if I divide both of these by negative 16, I will have x minus 2. 32 divided by negative 16 is negative 2. Just make sure if you did the distributive property, make sure you would get back your original expression. So that's it. This is the standard form equation of this parabola. Again, I guess they wanted me to write it right here, so I will oblige them. Okay, the vertex will be the opposite of these two numbers, but you must be careful. This one is not in the right order. I can't just go negative 5, positive 2, and that's my vertex. the x-coordinate of my vertex must come from the x part of the equation. So I will have a positive 2 because of the negative 2. Because of this positive 5, I will have a negative 5, but the y-coordinate of my vertex must come from the y part of the equation. For the p-value, I know that this negative 16 is 4p. So 4p equals the negative 16. Dividing both sides by 4, that tells me that p is equal to negative 4. So that is going to be it for problem number 18. For the last few problems, we are given a couple pieces of information pertaining to a parabola, either the focus, the directrix, or the vertex. They're going to give us 2 of those 3 things. And we're supposed to take that information and figure out the standard form equation of the parabola. The most important thing to do is to draw a picture, make a diagram. So let's see. They're giving me the focus and the directrix. Let's graph both of these. Now the focus is at 0, negative 4. So that means that the focus is right here. This is 0, negative 4. They tell us that the directrix is y equals 0. Y equals a number is always a horizontal line. So we're talking about a horizontal line at 0, which means the x-axis. So this is the directrix right here. Okay, so this is the focus and the directrix. Now, remember, imagine that this red dot right here is the focus, and then this red line down here, this dotted line, is the directrix. The vertex should be right in the middle between them. All right, because if you go from the vertex to the focus, that's P. If you go from the vertex to the directrix, that's also P, but in the negative direction. So, looking at our diagram, the vertex of this parabola should be halfway between these 2 things. So that means, of course, that the vertex should be right here. We also know that this parabola will be facing down because it has to be facing away from the directrix. So this gives us a lot of the information that we need to write the equation. Because we now know that the coordinates of the vertex are 0, negative 2. The vertex is 0, negative 2. We also know that this is a vertical parabola because it's facing down. And whenever we have a vertical parabola, we use this model where the x portion of the equation is squared. Okay, so we're thinking about this. The model is x minus h squared is equal to 4p times y minus k. All right, this is the model that we're going to use. But now we know, since the vertex is 0, negative 2, this is h and this is k. So if this is 0, then I will really just have x squared. And now I have 4p, now y minus k, in other words, the opposite of this. So I will put y plus 2, not squared. So all I really need is the p-value to finish this off. But look, we have learned that the p-value is the distance from the vertex to the focus. That's the p-value. So from the vertex to the focus, this is down 2. So that means that my p-value is negative 2. So substituting negative 2 in here, I have x squared is equal to 4 times negative 2, which means that x squared is equal to negative 8 times y plus 2. And there's our equation. Okay, so hopefully you can see that it was all about the diagram. Alright, let's do the same thing with number 20. The focus is at 6, 0. So that means the focus is right here. Now, they say that the directrix is x equals 0. X equals a number is always a vertical line. So we're talking about a vertical line at 0. Well, that's just the y-axis. So this is the directrix. Okay, so again, when you're talking about the focus and the directrix, the vertex should be right in the middle between the two. Okay, so the vertex of this parabola should be right here. Okay, and the coordinates of this vertex are 3, 0. We know that this parabola will be opening to the right, wrapping itself around the focus. So, because this parabola is horizontal, it's opening to the right sideways, we know that we are talking about this model, the one where the y portion of the equation is squared. So I like to just start by writing down the entire model. So we're talking about y minus k squared is equal to 4p times x minus h. Now, the 3 and the 0, the coordinates of our vertex, that's the h and the k. Don't forget that it's the y coordinate that has to go here in the y portion of the graph. So since this k is 0, then this will just be y squared. Alright, and then we will have 4p times x minus h. That means the opposite of this, so x minus 3. So all we need is the p-value to complete the equation. Well, the p-value is the distance from the vertex to the focus, all right, including the sign. So the p-value is positive 3 because from the vertex to the focus, we're going 3 to the right. If it had been to the left or down, it would be a negative 3. Since p is positive 3, substituting that back into the equation right here, then that'll be 4 times 3 times x minus 3. So we have y squared is equal to 12 times x minus 3. And that is it for number 20, standard form equation. What else you got? Let's do 2 more. The vertex is at 5, 1. Alright, so on a graph, that would be about here, 5, 1. The directrix is y equals negative 3. Now, y equals a number is always a horizontal line, so we are talking about a horizontal line at negative 3. So this would be the directrix right here. Okay, so right away we know this is an upward facing parabola. Okay, so we know we're dealing with this. Alright, the parabola has to be opening away from the directrix. Now we need the focus in order to talk about the p-value that we're going to need. In fact, let's go ahead and write down what we have so far. Because this is a vertical parabola, we know that this is the version that we're going to use. This is the model equation that we're going to use, the one where the x part is squared. So I like to start by writing down the whole model. So x minus h squared is equal to 4p times y minus k not squared. We know the vertex already. So this, because we know that the vertex is 5, 1. So this is going to be my h and my k, right? This is the h, k. So that means my equation becomes x minus 5 squared is equal to 4p times y minus 1. It's the opposite of these two, really. So to complete the equation, all I need is the p-value. The p-value is associated most directly with the focus, which is going to be up here somewhere. But they didn't give me that. They gave me the directrix instead. So that's okay, because remember that the distance to the focus and the distance to the directrix are the same, except that one will be positive and one will be negative because they're in opposite directions. So if we look at the distance to the to the directrix, how far down is this? Okay, well, we went from 1 to -3. So that was down 4. That means that the focus should be up 4. So if I went up 4, that's going to put me right here. Okay, so there's my focus, because I know that the p-value, looks like it's a little bit off to the side. The p-value is going to be positive 4, since the distance to the directrix was -4. Alright, it's going to bug me. So I just needed the 4. So the p value is 4, so if I substitute that into the equation, then now I have 4 times 4 times y minus 1, which gives me x minus 5 squared is equal to 16 times y minus 1. And that's it. That's the standard form equation of the parabola with this vertex and this directrix. Let's do one more and then we'll call it a day. So the vertex is at 4, 5. So 4, 5, so here is my vertex right here. Now the directrix is at x equals 5. X equals a number is a vertical line. So we are talking about a vertical line at 5. Okay, so my directrix will be a vertical line at 5, so that'll be like this. So right away, I know that we are talking about a parabola that is facing to the left, like this. Now, because of that alone, I know which model I'm going to choose. A sideways parabola, a horizontal parabola, will always have the y part of the equation squared. So I'm going to use the model that goes y minus k squared is equal to 4p times x minus h. And we already know the vertex. Okay, the vertex was 4, 5. Okay, that's the vertex right there. So that 4 and 5 is my h and my k. So I can use these to fill in the parentheses. Be careful, this equation is backwards in terms of the coordinates of the vertex. The y coordinate of the vertex will give you the y part of the equation. So this 5, the y coordinate, is going to turn into y minus 5 squared. And I still have 4p times, and now the x value of the coordinate will give us x minus 4 in the equation. So be careful because they're backwards. Again, all we need is the p-value. The p-value is associated with the focus, which is going to be in here somewhere. But where? Well, we can use the directrix to help us. So how far is it from the vertex to the directrix? What is that? Well, the vertex is at 4 and the directrix is at 5. So that's a distance of 1. Because it's to the right, I'm going to call it positive 1, plus 1. So that's the distance from the vertex to the directrix. We have learned that the distance to the directrix and the distance to the focus are the same. Only one will be positive and one will be negative. They're opposites. So if the distance to the directrix is positive 1, then the distance to the focus should be negative 1. Okay, in other words, if I go left 1 unit, that is going to give me the focus. Okay, so that tells me that the p-value, now I'm not sure why the way, I have the positive 1 looking a lot bigger than the negative 1, but I don't know. This is tough to do without graph paper. But hopefully you can see even that these are supposed to be the same, even though this looks longer and this looks shorter. So the p-value is negative 1 because it's going to the left. So p is equal to negative 1. If I substitute that into the equation, then I get y minus 5 squared is equal to 4 times negative 1 times x minus 4. So that gives us negative 4 times x minus 4. And that's it. I forgot what it was. X minus 4. So that is it for number 22. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.